Okay, hello everyone. So let's look at this exercise, 3I, the discriminant. In the last exercise, we looked at the general quadratic formula. And if you remember, that was used to find the solutions, okay, or really it was the x-intercepts, okay. So this gave us the x-intercept, so that plus and minus gave us one intercept, and then the minus would have given us the other intercept. The discriminant is just looking at this part in here, and so we tend to write the discriminant. We use a Greek symbol delta, or a little triangle, is b squared minus 4ac. So that is our key bit of information. So what to find is if we want this, if we want to find this, okay, using this formula, when we use this formula, if we get this to be in here, negative, so the square root of a negative number, you can't define it. So if, I'll find a pencil, so, oops, don't want red. So if that is less than 0, so if the discriminant is negative, oops, my pen's not working, then there's no solutions. And if you think about it, you can't take the square root of a negative number in the real number plane. There's imaginary numbers, but we're not going to go into that. That's for our specialist. So we've got this, so it's negative. It's got no solution. So what that means is if we have our graph, right, that means our graph is going to be either up here, over here, it could be down here, it could be down here. But whatever the case, it's not going to hit this x-axis. So there's no solutions, okay? So keep that in mind. Then we've got another situation where our discriminant might equal 0. So if discriminant equals 0, we're going to get it where there is only one solution. So our graph will just touch it there, or it might just touch it there, might just touch it there. So that means there's only one solution. So the graph just touches, or it's the turning point, is on the axis, on the x-axis, okay? Oops, can't even spell it. Axis, gosh, I've gone blank at the moment. So we've got that. So obviously we've looked at less than 0, so it means that the graph doesn't touch it. We've got equals 0, where we've got it so it just touches. So obviously we've got one more where it's greater than 0, and that's where there's 2 x-intercepts. And if I draw my graph, I'll just change the colour here, I might do a green one now. It means that our graph's going to cut that way or that way, so we're going to get intercepts there, intercepts there. So we're going to get 2 intercepts. So if this is basically positive, we're going to get 2 intercepts. Okay, if it's negative, there's no solutions, and if it's equal to 0, then it's just touching. So they're the 3 situations. So I'll go over the page and we'll do an example. Okay, so let's have a look at this. What have we got? We've got that, so, oops, sorry, just get that up. A equals 3, B equals 8, and C equals 7. So exactly the same as what we did with our general quadratic formula. Now we're just going to find that part of the b squared minus 4ac. So we put these values in, and we get b squared is 8 squared minus 4 times 3 times 7, and 8 squared is 64. Now minus 4 times 3 is 12 times 7 gives us, what's that, 84, and that's going to equal negative 20. So what we've got is this is negative value, so that means that that's less than 0, it's negative. So once it's negative, we know that there's no real solutions. That means if we have a look at this graph, if you think about it, this is a y-intercept's going to be plus 7 because x equals 0. So if we drew our graph, it's going to looks probably something like that with our y-intercept up here. So there's not going to be a x-intercept. So that's what this means. Okay, so it's going to be stuck up there somewhere like that. If I look at another question, what have we got over here? Let's see. Let's get a one with some nice numbers. Sorry. X squared plus 2x minus 4. So once again, my a is going to be equal to 1, my b is going to be equal to 2, and my c is minus 4. So if I put them together in our b squared minus 4ac, I'll put that little bit of there, and where are we? So that's going to equal 2 squared. Whoa, that doesn't look, my writing's got really crappy then. So 2 squared minus 4 times 1 times minus 4. Now this is where people make the mistake, this minus and a minus. This is why I tend to do it in brackets, so I know that I've got to times all of these. So my 2 squared is 4, and then I've got negative 4 times negative 4, which is going to give me my plus 16. So that's going to equal 20. So that means it's greater than 0. So my discriminant is greater than 0. So I'm going to have two solutions. Now if I think about my graph, okay, my y-intercept is going to be here at minus 4. So if and it's a vertical graph, so if I've got that minus 4, so obviously I'm going to have my two solutions there. So really that's all we do, and obviously if you're going to get one where delta equals 0, then you know that it's just touching the graph. And that's all you do for those, but there's a couple of harder ones, so I'm going to give an example of a harder one on the next page. Rightio, so what we've got is we've got this equation here, and it's going to look different because it's got some m's in it. So what we've got to do is we've got to find out what our discriminant is. So let's find our A is 5, our B is negative 5m, so we just do this exactly the same process, and minus m. So we've got that, we've got our minus 5m, we've got our minus m. So now we just put that into our discriminant, and we know that's b squared minus 4ac. So our b squared is going to be minus 5m all squared minus 4 times 5 times minus m. So we end up getting 25m squared because a negative times a negative, so minus 5m times minus 5m gives us that. We've got a minus times a minus, so I know that that's a plus, and that's going to be 20m. So that's what my discriminant equals. So if I was, so the question will ask me, for 1, I want delta for, I want to find m for 1, no solutions. Okay, and so that's when the discriminant is less than 0, so when it's negative. So what I've got here is I've got a quadratic equation. I've got a squared, I've got an m. So what I'm going to do is I'm going to factorise that. I'm going to take a 5m out, and I'm left with 5m minus 4. What I'm going to do, so part 1 was that, part 2, m for one solution, and that's when delta equals 0, and obviously 1, 2, 3, part 3 will be m for two solutions, and that's when delta is greater than 0, or discriminant, sorry. So how am I going to find this? I want the values of m. So you've done this before, and it's just meant if I'm going to graph this, but instead of having x and y, so I'm going to graph this quadratic. Instead of having x and y, I'm going to have m and delta. So if you think about that, that's the same as y equals 25x squared plus 20x. If this is my 5m, so that means if I was to find my, just change this to green, so if I was going to find my x-intercepts or my n-intercepts, I get m equal to 0 and m equal to, rearranging this equation, it's going to be 4 over 5. So my graph is going to go through 0. That's going to go like this. So there's going to be my 0 point. There's going to be my 4 over 5. So if I think about this, going back to when we were doing inequalities, quadratic inequalities. So here's my quadratic. I've factorised it. I've got my x-intercepts. And instead of x and y, I've got m and delta. So here's my thing. So now we're using what we did in 2 exercises ago. We're doing this. So we've got m for no solutions. When delta is less than 0. When is it less than 0? So this is our 0 line. So it's this part here. So how do we do that? That's going to be between, I know m is in between those. So there we go. And I know it's going to be open because of this. Okay, so it's going to be those symbols. M for one solution. Okay, so that means that value of m is when it equals 0. So that's going to be that point there and that point there. So it's when x equals 0 or 4 over 5. Then I've got when it's greater than, so that was this part here and this part here. So this is all the values x or m is less than 0. So m is less than 0. And we've got x or m is greater than 4 over 5. So we've followed through exactly the same. This is drawing on our graphing quadratic inequalities. So the same process. So you've got the skills, you've got the knowledge. It's just applying it to a slightly different situation. Okay, so good luck with that. Give me a hoy if you get stuck.